So chapter 11 electricity part 3. So in this we are going to discuss about the combination of resistors, series combination as well as parallel combination, and heating effect of electric current and its application and electric power. So first, what is meant by combination of resistors? When two or more resistors are combined or joined together into a form of a network, that type will be calling it as the combination of resistors. So we are having two types of combination of resistors again. One is called as series combination and another one is called as parallel combination. So there are two combination of resistors again, series combination and parallel combination. So first, what is meant by series combination? When two or more resistors are connected in a form of end to end. The end of the first resistor is connected to the end of the second resistor, like this means. Then we can say that the given combination is in a form of a series. Not only the diagram, it need to be like this, even if the given diagram is in this format also. Here also the given combination is in a form of a series. Why? Because the end of the first resistor is connected to the end of the second resistor and end of the second resistor is connected to the end of the third resistor. In series we need to remember important condition. The magnitude of current will remains the same. Suppose for example, in this resistor 5 ampere of current is passing, means here how much ampere of current will pass, they will be asking the question. In second resistor also the same amount of current will pass. Clear? Whereas the potential difference will vary from one resistor to the another resistor. It will change from one resistor to the another resistor. Remember the condition. In series combination, current flow will remains the same, whereas the potential difference will vary. Now we will derive an expression for the series combination of resistors. So look at the circuit diagram. Is it connected in a form of end to end or it is connected in a form of a common point? So if you are observing the circuit diagram, all the three resistors are connected in a form of a end to end. So now let's take the net potential difference will be equal to the sum of potential difference created across the ends of each resistor. So you can say that the net potential difference which is created across the ends of will be equal to the sum of potential difference created across the ends of each resistor. Then we can write over here it as V is equal to, sum means we all know it's nothing but called as the addition, add. So you can write it as V1 plus V2 plus V3. V is equal to V1 plus V2 plus V3. Now from Ohm's law, what is Ohm's law formula? V is equal to I into R. From Ohm's law, V is equal to I into R. Now in the place of V, we are going to substitute as I into R is equal to I1 R1 plus I2 R2 plus I3 R3. Now, as I said earlier, in series combination, the magnitude of current which is passing through each resistor, I1, I2, I3 will be equal to same. Since here we doesn't know the magnitude, we can assume the value of I1, I2 and I3 as I itself. Now, in the place of I1, I2, I3, we are substituting as I means what will happen? IR is equal to I R1 plus I R2 plus I R3. Now look at the right hand side term alone. which is common over here? I is common. Take that alone outside. IR is equal to I. If I took I alone outside, means remaining what will be there? R1 plus R2 plus R3. So in right hand side and left hand side, what is common? I is common. Cancel that 2. Remaining what will be there? R will be equal to R1 plus R2 plus R3. So what type of combination it is? The given combination is in a form of series. So in general format, how we can write this one means R equivalent is equal to R1 plus R2 plus R3 plus up to infinity. Suppose 4 resistors are there. Then how the formula will rearrange? R equivalent is equal to R1 plus R2 plus R3 plus R4. If only 2 resistors are there, means you can write the formula R is equal to R1 plus R2. Now, for example, let's take the resistance of R1 is 2 ohm and the resistance of R2 is 4 ohm and the resistance of R3 is 6 ohm. Let's take a value like this and then we'll try to calculate the net resistance in series combination. So what is the formula? R is equal to, totally how many resistors are there? 3 resistors are there. Then I can write the formula as R is equal to R1 plus R2 plus R3. Now R is equal to, what is the value of R1? 2 plus 4 plus 6. If we are adding all the numbers, the net resistance in series combination will be equal to 12 ohm. So from this we can conclude that in series combination the net resistance will be high, or you can use the term maximum. In series combination the net resistance is going to be high. In our textbook we will be having a question, calculate the net resistance which is having highest. Highest means it represents the given combination is in a form of a series. The given combination is form of series combination. And second condition is this net resistance. That means R equivalent will be greater than the resistance of each resistor. Resistance of each resistor. Always in series combination the net resistance will be greater. Compared to what? Compared to the resistance of each resistor. Here if you are observing, the net resistance I got as 12 ohm. So this 12 ohm is greater than 2 ohm, 4 ohm as well as 6 ohm. And one more condition is that the net resistance will be greater than the maximum. In this given combination, which one is the maximum? The third resistor is the maximum. 6 is going to be the maximum. The net resistance will be maximum than the individual resistance of resistor. Always the net resistance will be greater than the maximum individual resistance of resistor. Suppose the given combination is like this: R1 is equal to 2 ohm, R2 is equal to 12 ohm and R3 is equal to 6 ohm. Means here what will be the net resistance? Either it will be greater than 2 or greater than 6 or greater than 12. The net resistance will be greater than the 12. Why? Because in those given combination, which one is the maximum? 12 is the maximum. If you are adding all the numbers, 12 plus 8, 6, 18, 18 plus 2, 20. R equivalent is going to be 20 ohm. So this net resistance is greater than the maximum individual resistance of resistor. And then as per the Ohm's law formula, we know the relation resistance is inversely proportional to current. Resistance is inversely proportional to current. That means if resistance is high, in what combination? In series combination, the flow of current will be low. The flow of current will be low, or the flow of current will get decreased. In what type of combination? In series combination. Next, what are the important features? This is what I said. So So in series combination, the net resistance will be high or highest. The net resistance will be greater than the resistance of each resistor. That too, the net resistance will be greater than the maximum individual resistance of resistor. Since the net resistance is high, the amount of current which is passing through the circuit will get decreased, as resistance is inversely proportional to the current, from which relation we said means from the Ohm's law relation, resistance is inversely proportional to I. Now the next some numericals are there. So look at the circuit alone and then say what type of combination it is. The given combination is in a form of series. Why we said it as series? Because the conductor and the lamp are connected in a form of a end to end. So now write the resistance of the conductor. So what is the resistance? Sorry, first lamp is given, right? What is the resistance of the lamp? Let's take it as R1. R1 is equal to 20 ohm. And the conductor of resistance R2 is equal to 4 ohm are connected to a battery of V is equal to 6 volt. Calculate the total resistance, that means R equivalent we need to find. Calculate the current through the circuit we need to find, and the potential difference across the lamp as well as the conductor. Why they are asking separately means we all know in series combination the potential difference will vary from one resistor to the another resistor. First let us calculate the R equivalent. So what is the formula? Rs is equal to R1 plus R2. Reason we are using only up to R2 because only two resistors are there. So what is the value of R1 over here? R1 is equal to 20 plus R2 is going to be 4. Then the net resistance will be equal to 24 ohm. Now the second one, what are you going to calculate? I we are going to find. So what is the formula? I is equal to V by R. So I is equal to, what is the value of V? It is given in the question. 6 volt is here. So 6 by 24. Now simplify these two numbers. 1 6 r, 4 6 r. So 1 by 4 it is there. So therefore if you are dividing 1 by 4, it will be equal to, I is equal to 0.25 ampere. I is equal to 0.25 ampere. Now, so here suppose we are asking a direct question. In a given circuit, the amount of current which is passing through the conductor is 0.25 ampere. How much amount of current will pass through the bulb if they are asking means, we don't want to calculate anything, directly you can write it as through the bulb 0.25 ampere of current will pass. Why? Because in series combination the flow of current is going to remain the same. Now third, we will try to calculate the potential difference. So what is the formula to calculate the potential difference? V1 is equal to I into R1. V1 is equal to, what is the value of I? 0.25 into, what is the value of R1? 20 ohm. If you are multiplying these two numbers, we will be getting the answer as 5 volt. So what is the value of potential difference across the conductor alone? The potential difference across the conductor is going to be 5 volt, like that. Second, V2 is equal to I R2. So V2 is equal to, what is the value of I? 0.25, and what is the resistance of the lamp is given? 4. So V2 is equal to 0.25 into 4, 1 volt. So how we can check the answer what if found? Is it right or wrong? So in the starting itself, for the derivation of series combination of resistors, I said that net potential difference will be equal to the sum of potential difference created across the ends of each resistor. So here there are totally two resistors there. Clear? So you can write the formula V is equal to V1 plus V2. What is the value of V1? We calculated 5. And what is the value of V1? V2 we calculated 1. So V is equal to 5 plus 1 is going to be 6 volt. So if you are observing over here, the net potential difference which is created across the ends of each resistor is equal to the net. Clear? So you can say that the net potential difference will be equal to the sum of potential difference which is created across the ends of each resistor. If you are observing these two values, both the values need to be same. Then you can say that the answer what you found is going to be correct. Next question, draw a schematic diagram of a circuit consisting of a battery, 3 cells. Totally how many cells are there? 3 cells of 2 volt each. That means what is the potential difference of each cell is going to be there? Each cell is going to have a potential difference of 2 volt, and totally how many cells are there? 3 cells are there. Then you can write it as 3 into 2 is equal to 6 volt. And then this larger vertical line is called as positive and smaller line is called as negative. Always the negative terminal must want to be connected to the positive terminal of the another cell. Now, a 5 ohm resistor, an 8 ohm resistor and a 12 ohm resistor and a plug key are connected in series. Series means it's in a form of end to end. Totally how many resistors are there? 3 resistors are there. What are 3 resistors? One is 5 ohm, another one is 8 ohm and another one is 12 ohm which is connected along with the key. Clear? So you can just write it as R1 is equal to 5 ohm, R2 is equal to 8 ohm and R3 is equal to 12 ohm, and here symbol K. And we need to mention the direction of current in the form of a conventional. We all know conventional current means when current flows from higher potential towards the lower potential. Next, so they ask us to redraw the circuit of question number 1. So what did drawn over here? So we took a 3 cells over there, along with then 3 resistors are connected in a form of series and a plug key. So they are asking us to redraw. So we completed that one. So plus minus R1, R2, R3. So 5 ohm, 8 ohm, 12 ohm. Now, so in the question what they are saying, putting an ammeter. We all know for what purpose we are using the ammeter, in order to measure the current. And these two need to be connected only in a form of a series. And a voltmeter. For what purpose we are using the voltmeter? In order to measure the potential difference, and this one need to be connected in a form of a parallel. That too they specifically asking across the 12 ohm resistor we need to connect. So which one is the 12 ohm? R3 is the 12 ohm. Across the ends of the R3 we need to connect the voltmeter. And this need to be plus and this need to be minus. Now we need to connect the ammeter. Ammeter, wherever you want you can connect in the circuit, but it need to be in a form of a series. Either in this end you can connect, or over here, or in this place, or in this place, or even in between the resistors also we can connect. There is no problem, but it need to be only in a form of a series combination. So let's take any one alone. Yes. So let's take the ammeter is connected over here. Now, so in the question what they are asking, what would be the readings in the ammeter? Readings in the ammeter means they are asking us to calculate the current value. That means I we need to find. And the voltmeter reading, that too across the V3 we need to find. So if I need to find the current means, first we need to calculate the net resistance we need to find. So what is the formula to calculate the net resistance over here? Rs is equal to R1 plus R2 plus R3. So R is equal to, what is the value of R1? 5 plus 8 plus 12. So therefore Rs will be equal to 25 ohm. So what is the net resistance over here? R is equal to 25 ohm. Now we will need to calculate the current. So I is equal to V by R. So I is equal to, what is the value of V? It is given in the cell. That means the total potential difference 6 by, what is the value of R we calculated? 25. So simplify these two numbers. 6 divided by 25, that will be equal to 0.0 to 4 ampere. How much amount of current will pass through the circuit over here? I is equal to 0.24 ampere. That states that in each and every resistor, how much current is going to pass over here? 0.25. In the R1 0.24 is passing, means in R3 also the same amount of current only is going to pass. Now let's calculate the potential difference which is created across a third resistor. So V3 is equal to I into R3. V3 is equal to, what is the value of I? 0.24 into, what is the value of R3? 12. So now multiply these two numbers, 0.24 into 12, it's going to be V3 is equal to 2.88 volt. How much potential difference is created over here? V3 is equal to 2.88 volt. Now the next question, a battery of 9 volt is connected in series. Clear? So what is the potential difference of battery? They said it's going to be 9 volt. Is connected in series with the resistors of, totally how many resistors are there? 1, 2, 3, 4, 5 resistors are there. R1, R2, R3, R4, R5. So all the 5 resistors are connected in a form of a series. So what is the resistance of R1? 0.2 ohm. R2 0.3 ohm. R3 0.4 ohm and R4 0.5 ohm and R5 is going to be 12 ohm. And in the question, how much current will flow through the 12 ohm resistor? So look at all the 5 resistors, all are in a form of a series. Suppose in this resistor X ampere of current is passing, means in the all remaining resistor the same amount of current only will pass. So in order to find this current, first I need to calculate the net resistance, then only you can easily calculate the current over here. So in order to calculate the net resistance, what formula we can use? R is equal to R1 plus R2 plus R3 plus R4 plus R5. R is equal to, what is the value of R1? 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So if you are adding all these 3 numbers, the net resistance RS will be equal to 13.4 ohm. RS will be equal to 13.4 ohm. Now this is going to be the net resistance of the given circuit. This is going to be the net resistance of the given circuit. Now let's calculate the current. So what is the formula to calculate current? I is equal to V by R. Actually there is a small correction is there in the question. In our textbook it will be given as 6 volt. We also change into 6 volt. Clear? So now I is equal to, what is the value of V? 6 by, what is the value of R? We calculated 13.4. Now divide these two numbers. 6 divided by 13.4 is going to be 0.447 ampere. R we can write it as I is equal to 0.45 ampere. How much amount of current is going to pass in the R5? R5 is going to be 0.45 ampere. Suppose if you are doing the same value what is given in this question, means I is equal to V by R. I is equal to V value gave it as 9 and R value we calculated as 13.4. Now divide these two numbers. 9 divided by 13.4, it's going to be I is equal to 0.671 ampere, or I can write this one as I is equal to 0.67 ampere. Next combination. What is the second type of combination? Having parallel combination of resistors. So what is meant by parallel combination? When 2 or more resistors are connected to a common point. When 2 or more resistors are connected to a common point, those types of combination will be calling it as parallel combination of resistors. When 2 or more resistors are connected to a common point. For example, Let's take, there are two resistors then, R1 and R2. If these two resistors, that means the end of both the resistors are connected to a common point like this, then we can say that given combination is in a form of parallel. The given combination of form of parallel. Clear? So in this, in parallel combination, the potential difference will remains the same. Why? Because it's connected to a common point. It's connected to a common point. Whereas the amount of current or the magnitude of current which is passing through each resistor will vary. Current will vary, whereas the potential difference will remains the same. That means the value of V will remains the same, whereas the potential current will vary from one resistor to the another resistor. Now we'll derive an expression for the parallel combination of resistors. So now look at the diagram. Totally how many resistors are there? 3 resistors are there. Then I can say that the net current passing through the circuit is equal to the sum of current passing through each resistor. Yeah, so you can say that the net current, suppose here I am connecting an ammeter. Clear? If you are connecting the ammeter in this placements, it's going to find the net current. So this net current will be equal to the sum of current passing through each resistor. So then how I can write net current means it is nothing but called as a total current. I is equal to sum of, that means we are going to add I1 plus I2 plus I3 again from Ohm's law. So what is the Ohm's law formula? V is equal to I into R. If I need I means how the formula rearrange? I is equal to V by R. Then instead of I we can substitute as V by R. Then how the first equation will rearrange? V by R is equal to V1 by R1 plus V2 by R2 plus V3 by R3. So in the place of I1, I2 and I3 we substitute as V by V1 by R1 plus V2 by R2 plus V3 by R3. As I said earlier, in parallel combination the potential difference will remains the same. Therefore we can write it as V1 is equal to V2 is equal to V3 is equal to V. Now how we can rearrange this equation? V by R is equal to V by R1 plus V by R2 plus V by R3. In the right hand side term V is common, take that alone outside means remaining what will be then? 1 by R1 plus 1 by R2 plus 1 by R3. Now V and V will get cancelled each other. Remaining what will be then? 1 by Rp. Reason parallel combination. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So in general format how we can write this one means 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus up to infinity. Then you can say that 1 by means we all know that it's going to be reciprocal. So if you are they won't directly say the word derive an expression for series combination or parallel combination. For series means they will be using the word sum, or parallel means they will be using the word reciprocal. So the reciprocal of net resistance will be equal to the sum of reciprocal of resistance of each resistor. Clear? And then for example, let's take the value of R1 as 5 ohm, R2 as 10 ohm and R3 as 15 ohm, and it will calculate the net resistance in parallel combination. So what is the formula over here? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Substitute all the values. 1 by R equivalent is equal to, what is the value of R1? 5 plus 10 plus 15. Now take the LCM of all the three numbers. So what are the three numbers we are having over here? 5, 10, 15 is there. So 5, 1 5 are 2, 3. Again 2, 1, 3. Then 3, 1, 1. So the LCM of all the three numbers is going to be 30. If you are multiplying all the numbers, 5 2s are 10, 10 3s are 30. So in order to get 30, by using what number? We need to multiply this 5. You can multiply by 6. The numerator also multiply by 6. Over here 3. Numerator also 3. In this place 2 and numerator also 2. If you are multiplying like this, means 1 into 6, 6. 3 plus 2. So now 1 by Rp is equal to 6 plus 3 9, 9 plus 2 11 by 30. 11 by 30. So since we need Rp alone, means we can take the reciprocal over here. Reciprocal means the denominator will go to the numerator and numerator will come as the denominator. So therefore Rp is equal to, here what is the denominator? 30 is the denominator, that will come as a numerator, and 11 is the numerator, that will come as a denominator. Now divide these two numbers. 30 divided by 11 is going to be, Rp is equal to 2.727 ohm, or we can write it as Rp is equal to 2.73 ohm. So based upon this condition, what we can say about the net resistance in parallel means, we'll write over here. In parallel combination, the net resistance will be low, or you can call it as the lowest. That too, the net resistance will be lesser than the resistance of each resistor. Net resistance will be lesser than the resistance of each resistor. So what is the value of net resistance we calculated over here? 2.73 ohm. So this 2.73 ohm is lesser than 5, lesser than 10, lesser than 15, as well as this net resistance is lesser than the least. In this given combination, which one is the least? R5 is going to be the least. This 2.73 is lesser than 5. Then I can say that the net resistance is lesser than the least individual resistance of resistor. And then the last condition, what you are going to say over here, based upon this, since the net resistance is low, in parallel combination the flow of current will get increased. Reason we all know, resistance is inversely proportional to the current. Now we'll see some numericals related to this condition. And then, so before that I will say what are the advantages, one of the important 2 mark or a 3 mark question. What are the advantages of connecting an electric device in parallel with a battery instead of connecting them in a form of a series? So the first thing is that we can provide a separate switches. Clear? We can provide a separate switches for each and every device. Since we are providing separate switches, means based upon the necessary we can use them, and the energy can be saved. Second advantage is that if one device stops working means that, or else if one device got damaged, the other device will continues to work without any issues. In what combination? In parallel. But if it is in a form of series, let's take, it's like this. The given circuit is like this. All the bulbs are connected in a form of end to end. If the second bulb got fused means the overall circuit will become as a open circuit. Then the remaining bulbs, it also will stops working. That means it is a disadvantage. But in parallel, it won't be like this. If one device got damaged means the other device will continues to work without any fault. And then third thing is that net resistance will get decreased. The net resistance will get decreased, so the current flow can happen easily. That means the current flow will get increased over there. And then since all the devices are connected to a common point, the potential difference is going to remain the same. In domestic circuit, the potential difference value is going to be 220 volt. Since the potential difference is same, that means it's going to be 220 volt. Each and every device will take the appropriate amount of current to operate. Clear? So these are the important advantages of parallel combination compared to the series. Next. And one more important conditions are then how to find the number of resistors in series combination or it's in a form of a parallel. Just know this relation alone. To find the number of resistors in series, we are going to use it as R is equal to N into R. And if it is for parallel means, we are going to use it as R is equal to R by N. We will be getting the question maximum based upon the parallel. We won't get any question related to the series. So just remember that one relation alone. For parallel, what is the relation? R is equal to R by N. So now let's take this is the equation number 1 and this is equation number 2. So now what we are going to do? We are going to substitute the equation number 1 in equation number 2. So what is equation number 2? V is equal to I into, what is the value of R? R value is nothing but called as R by N. How many are number of resistors? That means N we are going to find. Means how the formula will rearrange? The formula will rearrange it as N will go over here and the V will come and occupy in this place. Then you can say that N is equal to I into R by V. So remember this formula. This is a condition what you are going to use in order to calculate the number of resistors to be connected in a form of a parallel. Suppose if they are asking for series means how the formula will rearrange? V is equal to I into N R. If we need N means N is equal to V by IR. This is a condition for series and this is a condition for parallel. So what is the formula we are going to use in order to calculate the number of resistors in parallel? N is equal to I into R by V. Next. So look at the circuit diagram and see what type of combination it is. Since all the resistors are connected to a common point, then you can say that the given combination is in a form of parallel. Now, read the question. In the circuit diagram given in the figure 11.10, suppose the resistors R1 and R2 and R3 has the values of 5 ohm, 10 ohm and 30 ohm. So what is the value of R1 over here? R1 is equal to 5 ohm, R2 is equal to 10 ohm and R3 is equal to 30 ohm, which have been connected to the battery of V is equal to 12 volt. So V is equal to 12 volt. Calculate the current through each resistor they are asking. Each resistor means we all know in parallel combination the amount of current which is passing through each resistor will be varying from one resistor to the another resistor, and then they are asking us to calculate the total current. I we need to find, as well as the total circuit resistance we need to find over here. So now, first let us calculate the individual current. I1 is equal to V by R1. What is the value of V? 12 by, what is the value of R1? R1 is 5. So we are dividing these two numbers. So 12 divided by 5 is going to be 2.4 ampere. Like that, calculate for I2. I2 is equal to V by R2. What is the value of V? 12. Why for all the resistors we are taking it as 12 means because in series combination the potential differential remains the same. So the V by R 12 by, what is the value of R2? 10. 12 by 10 is going to be 1.2 ampere. Like that, I3 is equal to V by R3. 12 by 30. So 12 divided by 30, that will be equal to 0.4 ampere. Now, so these all the three values we calculated. Now what they are asking us to calculate? Total current. How we can calculate the total current? The total current or the net current will be equal to the sum of current passing through each resistor. That means if you are adding the current which is passing through each resistor, you will be getting the total current. So I is equal to, what is the value of I1? 2.4 plus 1.2 plus 0.4. So if you are adding 2.4 plus 1.2 plus 0.4, it is going to be 4 ampere. So I is equal to 4 ampere. This is going to be the net current passing through the circuit. Last, they are asking us to calculate the equivalent resistance. So what is the formula? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. What is the formula to calculate the net resistance in parallel? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So now 1 by R equivalent is equal to, what is the value of R1? 5 plus 1 by 10 plus 1 by 30. So 1 by R equivalent is equal to, in the previous sum we solved by using the LCM method. Now we will solve by making the denominator as common. Clear? So in order to make this 5 into 30 means you can multiply by 6, the numerator also 6. Over here 3, numerator also 3, and here 1, 1. So 1 6 are 6 by 5 6 are 30 plus 3 by 30 plus 1 by 30. So then you can say that since the denominator is common, it's going to be the LCM of all the three numbers. So then you can write it as 30, 6 plus 3 plus 1. So now 1 by R equivalent is equal to 6 plus 3 plus 1 is going to be 10 by 30. So therefore R equivalent is equal to 30 by 10. 0, 0 you can cancel each other. So R equivalent is equal to 3 by 1 is going to be 3 ohm. So what is the total circuit resistance over here? The total circuit resistance is 3 ohm. Next, judge the equivalent resistance when the following are connected in parallel. Total how many resistors are there? 2 resistors. What are 2 resistors? R1 is equal to 1 ohm and R2 is equal to 10 to the power of 6 ohm. So the number is in a form of exponents. So rearrange into a normal number. So to expand this one means you can just write it as 6 zeros. Clear? So now they are asking us to calculate the net resistance in parallel. So what is the parallel formula? 1 by Rp is equal to 1 by R1 plus 1 by R2. So 1 by Rp is equal to, what is the value of R1? 1, R2 10 lakhs. Now do the cross multiplication. This 10 lakh you can multiply by using 1, and 1 we can multiply along with this 1, and this 1 you can multiply along with the 10 lakhs. Then how the numbers will rearrange? 1 by Rp is equal to 10 lakhs plus 1 by 1 into 10 lakh, 10 lakhs. So 1 by Rp is equal to since we need Rp alone means we can take the reciprocal over here. 10 lakhs by 10 lakh 1. If you are dividing these two numbers, the net resistance will be equal to 0.99 ohm. The net resistance will be equal to 0.99 ohm. Next. So look at the circuit and then say what type of combination it is. It's in the form of a series combination. So in the question what they are saying, an electric lamp of resistance 100 ohm, a toaster of resistance 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. What is the resistance of an electric iron is connected to the same source that takes as much as current all the three appliances take? Clear? They are saying that through the same source they are connecting one more device. Let's take it as electric iron, and they are asking what is the resistance of iron if it takes the same current as it is all the three electrical appliances take. Since initially we don't know the amount of current, let's take the current which is taken by all the three devices, X ampere. Clear? X ampere. If the same amount of current is taken by the iron means, by that time what will be the resistance? That's what they are asking. Clear? Then first thing what you need to find, how much current was taken by each device. So in order to find the current, what you can do, we can use the formula I1 is equal to V by R1. I1 is equal to V by R1. So what is the value of V? 220 by, what is the value of R1? 100. So 220 by 100 is going to be 2.2 ampere. Like that, calculate for I2. I2 is equal to V by R2. So 220 by 50. If you are simplifying, it will be equal to 4.4 ampere. Next, I3 is equal to V by R3. V value is 220 and R3 is going to be 500. If you are dividing these two numbers, it will be equal to 0.44 ampere. So these are the individual current which is taken by the lamp, toaster, and then water filter. Suppose we need to find the net current. So how we can find? I is equal to I1 plus I2 plus I3. So I is equal to, what is the value of I1? 2.2 plus 4.4 plus 0.44. So the net current is going to be, I is equal to 7.04 ampere. So initially I said that X ampere, right? Now what is the current over here? Current is going to be 7.04 ampere. That means all the three devices are combinedly, how much current is taking over here? 7.04 ampere. If the same amount of current is taken by the iron means, clear? That means the iron also is taking the same current. So by that time, what is the resistance they are asking? So the R is equal to V by I. And in the question clearly they said that an electric iron is connected to the same source. That means it is connected to the same value of the potential difference. So the R is equal to, what is the value of potential difference? 220 by, what is the value of current? 7.04. So if you are dividing these two numbers, 220 divided by 7.04, that will be equal to, R is equal to 31.25 ohm. How much what will be the resistance of the electric iron? Electric iron is going to have a resistance of 31.25 ohm. Next, how can three resistors of resistance 2 ohm, 3 ohm, 6 ohm are connected to get a total resistance of 4 ohm? So if you are getting any question like this, means it's a type of trial and error method. So you are just going to try the combination. If you are getting the answer, means it's correct. If it is wrong, means it's going to be error. Clear? Now we all know the main two types of combination. What are two combinations are there? One is series. So initially let's try along with series combination. So 2, 3, 6. If I am adding all the three numbers, I am going to get it as 11 ohm. But in the question they are asking for 1 ohm and 4 ohm. So we tried in series, so it's wrong, it's an error. Now we'll go for the parallel. So what is meant by parallel combination? All the three resistors are connected to a common point. So now 2 ohm, 3 ohm, 6 ohm. So what will be the net resistance formula? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R equivalent is equal to 1 by, what is the value of R1? 2 plus 3, 1 by 6. Take LCM of all the three numbers, 2, 3, 6. So 2, 1, 3, 3. Again 3. So the LCM of all the three numbers is going to be 6. So in order to get 6, so 3. So here also 3. Here 2, then here also 2, and in this place 1, numerator also 1. 1 into 3, 3, 1 into 2, 2, 1 into 1, 1. This is 1 by R equivalent. So now 1 by R equivalent is equal to 6 by 6. Therefore R equivalent is equal to, again it's going to be 6 by 6. If you are cancelling these two numbers, you will be getting it as 1 ohm. So now we got the answer for B. So we tried along with the parallel and the answer we got, so it is the correct. But we didn't get the answer in the form of for 4 ohm alone. Then how we can try? So remember a condition for this alone. So whenever you are getting a question like this, how can three resistors of resistance, whatever the values it may be there. Remember a condition alone. Two resistors need to be series. Along with that, one resistor need to be in a form of parallel. Then how we can connect? Two resistors are in a form of series. That means it's in a form of end to end. Along with that, one resistor in a form of parallel. Either you can try like this, or the second combination is two resistors in parallel. Two resistors in parallel. Along with that, one resistor is connected in a form of series. Then how we can connect the combination over here? Two resistors are in a form of parallel. Along with that, one resistor is in a form of series. So if you are giving the combination like this, means for any one you will be getting the answer. Now let's try along with this one. Clear? So one resistor in series, along with that two resistor is in a form of a parallel. Now choose the value. So let's take it as this is R1, R2, R3. R1 is 2 ohm, R2 is 3 ohm, and R3 is 6 ohm. Now these two resistors alone are in a form of parallel. First simplify the two alone. So what is the formula? 1 by Rp is equal to 1 by R2 plus 1 by R3. So 1 by Rp is equal to 1 by, what is the value of R2? 3 plus R3 6. So do the cross multiplication. 1 by Rp is equal to 6 plus 3 by 18. Now 1 by Rp is equal to 6 plus 3, 9 by 18. So therefore Rp is equal to 18 by 9. So now if you are simplifying, 1 9s are 2 9s are. So the net resistance in parallel for the given network alone, it's going to be 2 ohm. Now these two resistors are simplified and we got a single resistor like this. and the net resistance of that combination is going to be 2 ohm. Along with that, one resistor is connected, that is over here. R1 is going to be 2 ohm. Now observe the final circuit. What type of combination it is? Series. Series means we all know formula is going to be R is equal to R1 plus Rp. What is the value of R1? 2. Rp 2. 2 plus 2 is going to be 4 ohm. That means we tried like this. So even if you are not getting the answer in this combination, means we can go along with this. Clear? Next. So the next one it is, what is the highest? Highest means already I said the given combination is in a form of series, and lowest. Lowest means it represents the given combination is in a form of parallel. Clear? The word highest represents the given combination is series, and the word lowest represents the given combination is parallel. Now, what is the highest and the lowest total resistance that can be secured by the combination of 4 cells of resistance, 4 ohm, 8 ohm, 12 ohm and 24 ohm. First let us calculate for highest. So the highest means, as I said earlier, it is going to be series. So what is series formula? R is equal to R1 plus R2 plus R3 plus R4. So R is equal to, what is the value of R1? 4 plus 8 plus 12 plus 24. So if we are adding all the numbers, we are going to get it as 48 ohm. So the net resistance in parallel for highest combination, in series for highest combination is going to be 48 ohm. Now we will try for the lowest. Lowest means it is going to be parallel. What is parallel formula? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So now 1 by Rp is equal to 1 by, what is the value of R1? 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. Now we will make the denominator as common. In order to make the denominator as common means I can multiply by using 6, the numerator also 6, here 3, in this 3, here 2, here 2, and here you can multiply by 1. So if you are doing like this means 1 by Rp is equal to 1 into 6, 6 by 24 plus 3 by 24 plus 2 by 24 plus 1 by 24. Now we made the denominator as common means that is going to be the LCM. So 1 by Rp is equal to 24. Add all the numerators along, 6 plus 3 plus 2 plus 1. So 1 by Rp is equal to 12 by 24. But what we need? Rp we need. Since we need Rp, take the reciprocal on both the sides. So then how we can write this one? Therefore Rp is equal to 24 by 12. Simplify, 1 12s are 2 12s are. So the net resistance in parallel, that means the lowest resistance is going to be 2 ohm. So what will be the net resistance in parallel? Is going to be 2 ohm. Next, how many 176 ohm resistors in parallel are required to carry a 5 ampere on a 220 volt line? As I said earlier, how many? Number of resistors. So what is the formula? N is equal to I into R by V. Yeah, this is the formula what we are going to use in order to calculate the number of resistors in parallel. So what is the condition? N is equal to, what is the value of I? It is given in the question 5 into, what is the value of R? 176 by, what is the value of V? 220. V value is over here. So the N is equal to 5 into 176, it is going to be 880 by 220, 0 0 cancel, 122s are 422s are. So the number of resistors in parallel is going to be 4 resistors. How many number of resistors we need to connect in a form of a parallel? 4 number of resistors. Now, yes.